1500 BCE, somewhere in the Nile Delta, a water handler dropped mineral powder into a jar of brown river water. The transformation was not instant, it was slow, deliberate, beautiful. Particles that had floated for hours suddenly grew heavy. They drifted downward like snow falling in reverse, accumulating at the bottom, leaving the water above transformed. Not filtered, not boiled, collapsed, the mud falls first. The Egyptians knew this. They did not know the electrochemistry. They did not need to. They knew the result. Clear water, storable water, water ready for the next step. 3,500 years later, 69% of Canadian surface water treatment still uses the same chemistry. 45% of American aluminum sulfate consumption goes to water treatment. The principle George Warren Fuller proved in Louisville in 1895 runs beneath every city you have ever lived in. But open your emergency kit, check your survival supplies, search every preparedness guide sold in America. The chemistry is not there. What is there? A $3.24 billion industry selling you pump filters, membrane cartridges, and plastic systems, many containing the same destabilization principle the Egyptians discovered, wrapped in packaging, marked up, sold with a replacement schedule. Aluminum sulfate, alum, the first barrier in water treatment, the chemistry that makes everything else work. This is not a story about a powder that purifies water. This is a story about a principle so foundational that every water plant uses it, while the survival industry sold you cartridges instead. Welcome to Forbidden Manual. The archive opens in 1500 BCE in the Nile Delta, where water handlers discovered a principle that would outlast the pyramids themselves. The Nile was everything. It fed the crops, filled the cisterns, moved the commerce of an empire. But the Nile also ran brown. Sediment from 1,000 miles of African watershed poured into the delta every flood season, turning drinking water into something closer to liquid mud. Storage jars clouded within hours. Temple basins filled with silt. The river that gave life also carried suspended particles too fine to settle on their own. Then someone added a mineral powder. The transformation was not instant. It was slow, deliberate, beautiful. The water began to change from within. Particles that had floated for hours suddenly grew heavy. They drifted downward like snow falling in reverse, accumulating not on the surface but at the bottom. The sludge collected. The water above it cleared. The mud falls first. They coded it out. They can't code out physics. Subscribe. The next archive opens soon. Now let's get back to the investigation. This was not filtration. This was not boiling. This was chemistry, a deliberate intervention in the physics of suspension. The Egyptians had discovered coagulation, the principle that tiny particles repelling each other can be made to collide, combine, and collapse. They did not know the electrochemistry. They did not need to. They knew the result: clear water, storable water, water ready for the next step. 3,000 miles east and 2,000 years later, researcher Samia al-Ajarya-Jan documented what had survived in the river households of China. In her 2001 publication in the journal Water Supply, Jan traced clarification traditions that had never entered laboratories. Practices passed through generations of families who drew water from the Yangtze, the Yellow River, the Pearl. Less privileged populations, she noted, used highly turbid water and developed systematic practices for clearing it. Not an experiment, a tradition. Jan's work revealed something the modern world had forgotten. The chemistry that would later fill municipal treatment plants began in buckets. It began in households. It began with people who could not afford to wait for clear water to arrive and who discovered that a pinch of mineral salt could make it appear. The archive shifts now to 1895 to the banks of the Ohio River, where an American engineer named George Warren Fuller faced a problem that was killing cities: Louisville, Kentucky. The Ohio runs brown with sediment and sewage. Typhoid fever is epidemic. Cholera outbreaks strike with seasonal regularity. American cities are dying of waterborne disease, and no one has yet proven that municipal water treatment can work at scale. Fuller designed the Louisville water filtration experiments. From 1895 to 1897, he tested what the Egyptians had known and what Chinese households had practiced: pre-coagulation with aluminum sulfate before rapid sand filtration. The results transformed American public health. The Ohio River ran brown. Fuller added alum. The flock formed, settled, and the water above it was ready for the next stage in treatment. Not pure yet, but treatable. Not safe yet, but preparable. The Egyptians knew The Chinese households knew. Fuller measured it. The chemistry has not changed. The physics has not moved, only the packaging. 3 civilizations, 3,500 years. One principle that modern survival culture somehow forgot. You cannot disinfect what you cannot see through. Clarification comes first. It always has. But how does a pinch of powder collapse an entire bucket of mud? In 2010, a research team published something that should have rewritten every survival manual on the market. Kelsey Preston, Daniele Lantain, Nadine Kotlars, and Kristen Jellison, a research team linked to Lehigh University, published their findings in the Journal of Water and Health. They had tested aluminum sulfate flocculation at turbidities ranging from 10 to 300 NTU, measuring not just how much mud the powder could drop, but what happened to the water afterward. The results were not subtle. Turbidity reduction ranged from 23 to 91%. The dirtier the water, the more dramatic the clarification. But the critical discovery was what happened next. Chlorine demand dropped. The water that had consumed disinfectant before it could kill pathogens now held onto the chlorine long enough for it to work. The water became disinfectable. This is the physics that survival training never taught you. Tiny particles of clay, silt, bacteria, and organic matter stay suspended in water because their surface charges repel each other. They float, they scatter light. They hide pathogens inside the structure. They consume chlorine before it can reach anything alive. The water looks dirty because physics is keeping the dirt airborne. Alum is the key that unlocks that suspension. When aluminum sulfate dissolves, it releases positively charged aluminum ions that neutralize the negative surface charges on suspended particles. Suddenly, particles that spent hours repelling each other begin to collide. They stick, they grow. Flock forms. You can watch it happen. Visible clumps appear in the water, drifting downward like snow in a jar. The sludge accumulates at the bottom. The water above clears. Not filtered, collapsed. Not boiled, destabilized. The chemistry does in minutes what gravity alone could not do in days. Not magic, electrochemistry. In 2024, not 1895, a research team led by Hicham Tarawi at the University of Ferhat Abbas in Algeria published a year-long study on highly polluted surface water. They used aluminum sulfate and jar testing to optimize coagulation across seasonal variations in water quality. The result, in their words, very effective elimination, was significant reduction across the majority of physicochemical parameters. The chemistry still works, it never stopped working, but here's a lesson that survival culture forgot. The lesson that could save your life or end it. Clear is not safe. Flocculation removes what you can see. It drops the mud, the silt, the suspended organic matter. It makes the water beautiful. But viruses do not scatter light. Bacteria can survive in crystal clear water. Dissolved toxins do not form flock. The powder is the first barrier. Disinfection is the second. Skip the second and clarity becomes a fatal illusion. The World Health Organization published the operational constraint that every emergency kit ignores. Under optimized conditions, residual aluminum in treated water can be controlled to 0.1 milligrams per liter or less, but that requires proper dosing, pH control, and adequate separation time. The chemistry is simple. The execution requires understanding. Understanding that was never taught. Consider the economics. A 10-liter P&G purifier of water sachet, ferric sulfate for coagulation plus calcium hypochlorite for disinfection costs 3.5 cents in humanitarian supply channels. Retail survival branded pump filters cost $50 to $200. The chemistry inside both systems operates on the same principle the Egyptians discovered. One powder, one stir, one settling period, then the kill step. Clarification is not purification, but purification starts here. If this chemistry is so effective, if it still runs 69% of Canadian surface water treatment and 45% of American water treatment, why has no survival manual, no emergency preparedness kit, no household water guide ever taught you how it works? The EPA does not ban aluminum sulfate. The EPA does not hide it. The EPA requires what aluminum sulfate cannot do by itself. Under the surface water treatment rules, public water systems drawing from surface sources must filter and disinfect. Coagulation is embedded in that sequence. It is the first step in virtually every municipal treatment plant in the country. But the rules require multi-barrier treatment. Clarification alone does not qualify. The regulations are not wrong, but they created a framework where understanding the first step became invisible. The chemistry that clears your city's water never made it into your emergency kit. The principle that makes disinfection possible was buried under brand names and cartridge systems. The first barrier disappeared not because it failed, but because it was reclassified as insufficient on its own. The World Health Organization built a validation system for household water treatment technologies. The international scheme, as it is called, tests products before they can be recommended for emergency use or humanitarian distribution. In their own published language, the purpose of the scheme is to ensure that products with limited or no pathogen removal are kept off the market. Coagulation and flocculation are tested only against protozoa, not viruses, not bacteria. The chemistry that runs every treatment plant on Earth does not qualify as a complete household solution. The regulations protect public health. The validation protects consumers. But the effect is the same. The first barrier was never taught. What filled the gap? $3.24 billion. That is the portable water purifier market as of 2025, according to industry analysis. Katadyn, Sawyer, LifeStraw, MSR, Brita. The companies filling that market are not selling magic. They are selling packaging, membrane filters that clog in turbid water, pump systems with plastic parts that crack in storage, cartridges that require replacement every few hundred liters, activated carbon that cannot handle the sediment load of actual emergency water sources. The chemistry underneath many of these systems, the same destabilization principle the Egyptians discovered, wrapped in plastic, marked up, sold with a replacement schedule. You cannot patent electrochemistry. You cannot subscription model a bag of powder. You cannot build a $3.24 billion industry on a technique that costs cents and fits in a sandwich bag. But you can build that industry by wrapping the same chemistry in a cartridge, a membrane, a pump mechanism, and a brand name. You can sell the solution to a problem while never teaching the principle. They built validation systems that test coagulation only against protozoa, not viruses, not bacteria. They publish emergency guidance that mentions Alum in pre-treatment footnotes while the main text promotes branded sachets. They created a retail survival market where a $200 pump filter sits next to a $2 bag of powder, and the filter gets the shelf space, the marketing budget, the consumer attention. They trained a generation of preppers to stockpile cartridges instead of understanding chemistry. They taught you that clear water needs a brand name to be safe. You are standing over a bucket of floodwater, brown, opaque. Your children are thirsty. The survival filter you bought 3 years ago cracked in the garage. The cartridge is clogged with the first liter you tried to pump. You have no replacement. You have no backup. You have no idea that a $5 bag of powder, the same chemistry that clears every municipal gallon in your city, could have made that water treatable in 20 minutes. Treatable, not drinkable, but treatable. Ready for boiling, ready for the chlorine tablets in your kit that were designed to work on clear water. Instead, you are staring at mud. The CDC acknowledges the challenge in their safe water system materials. The drawback of Alum, they write, is that the necessary dosage varies unpredictably based on water chemistry. That is real. Water varies. Dosing requires testing. But the solution is not to abandon the chemistry. The solution is to teach it. A jar test takes 5 minutes. You divide your sample into small containers, add different amounts of coagulant to each, stir, wait, and observe which dose clears the water best. This is not complex. This is not dangerous. This is how every water treatment plant on Earth operates, testing before treating. The survival industry chose to sell you cartridges instead. The chemistry was not suppressed, the knowledge was. You were never taught the first barrier. You were sold the last one. But the chemistry survived in humanitarian camps, in off-grid homesteads, in the emergency protocols of countries that never forgot what America stopped teaching. In the aftermath of Tropical Storm Jeanne in 2004, the streets of Gonibs, Haiti, filled with contaminated floodwater. The municipal supply was destroyed, open defecation mixed with standing water. Cholera and dysentery threatened to kill more people than the storm itself. A research team, Romulo E. Colindres, Seema Jain, Anna Bowen, Eric D. Mintz, and Pauliana Damon evaluated what happened next. Their findings, published in the Journal of Water and Health in 2007, documented the use of combined flocculant disinfectant treatment in Haitian households. A family stands over a bucket of brown water. A sachet is added, ferric sulfate for flocculation, calcium hypochlorite for disinfection, 5 minutes of stirring, 20 minutes of settling. The flock drifts downward, the water clears. Then the chlorine finishes the job. The children drink, not a filter, not a pump. Chemistry. P&G and the CDC reverse engineered a municipal treatment plant into a paper sachet. The purifier water system combines both barriers, coagulation, and disinfection in a single dose designed for 10 liters of contaminated water. In humanitarian supply channels, each sachet costs 3.5 cents. 3.5 cents, 30 minutes. 10 liters of drinkable water from floodwater that would have killed a child. The chemistry is not alternative, it is not fringe. It is the backbone of modern water infrastructure operating at household scale. Health Canada reports that aluminum-based coagulants are used in treatment for 69.2% of surface waters and 6.7% of groundwater sources in the country. The United States EPA estimates that water and wastewater treatment represents approximately 45% of domestic aluminum sulfate consumption. The same chemistry, it's the same physics, running silently inside every treatment plant while the retail survival market sells you cartridges. If you want to use it yourself, here's what the emergency guidance actually recommends. The protocol that footnotes mention and main text bury. You need aluminum sulfate, preferably potable water grade, with NSF certification. You need 2 clean buckets, a stir stick, cloth for decanting, and you need a disinfection method, a boiling setup or chlorine solution. The process is not complicated, but it requires understanding. First, the jar test. Divide a small sample of your source water into several containers. Add different amounts of alum powder to each. Start small, perhaps 1/8 of a teaspoon per liter, and increase incrementally. Stir each container vigorously for 1 to 2 minutes, then slowly for another 5. Let them settle. Observe which dose produces the clearest water without overdosing. That becomes your treatment ratio. Second, scale the dose to your full batch. Add the alum, stir vigorously to disperse, then slowly to encourage flock formation. Wait 15 to 30 minutes depending on turbidity. Third, decant. Pour the clarified water through cloth into your second container, leaving the sludge behind. Fourth, and this step is not optional, disinfect. Boil for 1 minute at a rolling boil, or add chlorine at the concentration specified for your tablets or solution, or use both if you have any doubt. Settling is not sterilizing. The second barrier is not optional. The cost of entry is minimal. Bulk aluminum sulfate in potable water grade runs approximately $1 to $2 per pound. A single pound can treat dozens to hundreds of liters depending on turbidity. Compare that to retail survival filter cartridges at $20 to $50 per replacement. Cartridges that often cannot handle high turbidity water without clogging. The cheapest chemistry is always the hardest to sell. This pattern repeats across every suppressed survival technique. Moringa seed flocculation, another natural coagulant used across sub-Saharan Africa, works, but CDC notes it can increase chlorine demand. The barrier is real, the solution is the same. Teach the full sequence, not just the first step. Cloth filtration with folded sari fabric reduces cholera transmission in Bangladesh. Cheap, simple, proven, and treated as a limited barrier in institutional guidance because it cannot remove viruses. Ceramic pot filters appear on WHO lists for post-emergency use. Low-tech, durable, locally manufacturable, and embedded in a procurement ecosystem that determines what aid agencies can purchase. Household chlorination, dirt cheap, massive public health impact, is often rejected by users because of taste and appearance. The cheapest life-saving intervention loses to preference and convenience. Alum was buried under branded filters. Moringa was buried under dose variability warnings. Ceramic pots were buried under procurement logistics. Cloth filtration was buried under validation categories. The cheapest survival chemistry is always the hardest to sell. The simplest barriers are always the hardest to market. Knowledge does not generate recurring revenue. They will not tell you that 69% of Canadian surface water treatment uses the same chemistry you can buy for $2 a pound. They will not tell you that a 3.5 cent sachet can transform 10 liters of floodwater into drinkable water in 30 minutes. They will not tell you that the physics has not changed since the Nile Delta in 1500 BCE, that the principal fuller measured in Louisville still runs beneath the streets of every city you have ever lived in. They will not tell you that the first barrier is not a product. It is a principle, and principles cannot be subscription modeled. 3,500 years. The Egyptian water handlers, the Chinese river households, Fuller on the banks of the Ohio, Preston and Lantane in the laboratory, Colindres and the research team in post-storm Haiti. The chemistry connects them all, a thread of knowledge that should have reached your emergency kit and never did. You were taught to buy cartridges. You were taught to trust brand names. You were taught that clear water requires plastic and pumps and proprietary membranes. You were not taught the first step. The chemistry does not care about your cartridge subscription. It does not require a brand name. It does not need a pump mechanism, a filter housing, or a replacement schedule. It waits in a bag on a shelf. It waits for dirty water in a stir stick and someone who understands that clarification comes first. It waits to teach you what the Egyptians knew, what Chinese households practice, what Fuller measured, what the survival industry buried under plastic and marketing. The first barrier is knowledge. The first barrier is chemistry. The first barrier is yours to learn. A chemistry you cannot patent. A barrier you cannot subscription model. A principle that asks for no cartridge, no membrane, no recurring purchase, no brand loyalty. The first step in water treatment is not a product, it is understanding, and understanding, once shared, cannot be unsold. Every share rebuilds what they forgot to teach. Every download preserves the first barrier. Every person who learns that clear water starts with chemistry, not cartridges, breaks the cycle that turns survival into a subscription. The mud falls first, then the killing begins. The Egyptians knew the sequence. The survival industry sold you the second step and buried the first. Now you know both. Next time on Forbidden Manual, a cooling system that runs on shadows. No compressor. No refrigerant, no electricity. Just physics the Persians mastered 2,000 years ago. Physics that kept ice frozen in the desert, and a building code that has never once mentioned it. The archive opens in the high plateaus of ancient Iran, where engineers built structures that manufactured ice in a climate that never dropped below freezing. The code calls it impossible. The ruins prove it